Hello everyone, today we are going to be solving this problem here. Okay, and this problem says if FB is 700 newtons and FC is 560, determine the magnitude and coordinate angles of the resultant force acting on the flag pole. Okay, so first things first, we need to see where the axes are, and you have the positive x right here. We have the positive y and we have the positive z. Okay, now we need to find those vectors that is mentioned on the problem, fb and fc. So fb is this vector here, and in order to have the vector we need to get the points. So point a is going to be an important point in our problem, as well as point b and point c. Okay, so let's get all these 3 points before we do anything in this problem. So I'm gonna write here point a is going to be equal to the x component of a is going to be 0, the y component of a is also going to be 0, and the z component of a is also going to be 0. Now we get the components of point b. So if you go towards the x, point b displays 2 meters. So for point b we have the x component 2, the y component, if here is the origin going against the positive axis, that will be -3, and in the z direction that will be going to be 0. And then we have point c, which in this case is this point right here. With respect to the x is going to be 3, with respect to the y is going to displacement is +2, and with respect to the z the displacement is 0. I had a very small mistake I just saw here. The displacement of z is not 0, but z is the height right here, okay, for at point a, which is going to be 6. I apologize for that. So in this problem we need to get those vectors. The vector here is the vector AB and the vector AC. So let's get those vectors first. So vector AB, that means that we have the subtraction between point B minus point A. And in this case, point B is 2 minus 0. So I'm gonna write here, but I don't need to do that. Minus point A, which is 0, 0, and 6. So here we have 2 minus 0 is going to be 2. We have -3, which 0 is going to be -3. And 0 minus 6 is going to be -6. Now we do the same for vector AC. So we do AC, and the vector is going to be the location C minus A. And for the location C we have 3, 2, and 0. And the location A we have 0, 0, and 6. So when you do the subtraction, is 3 minus 0 is going to be 3, 2 minus 0 is going to be 2, and 0 minus 6 is going to be -6. Okay, so now we have to in order to continue this problem, because what we have here is this vector FC, and also have this vector here, which is the vector B. In order to move on in this problem, we have to get the unity vector for both. Okay, so let's get the unity vector for the vector AB and BC. And before we do that, we need to get the magnitude of the vector AB and vector AC. So in order to get the magnitude, you have the vector AB is going to be equal to the radical of the component. So I have 2 squared plus -3 squared plus -6 squared. If you do this calculation, you're going to find out that this value is 7. Okay, and in this case that would be 7 meters. If you go to the AC, the magnitude of AC is going to be the radical of the components as well. And in this case, we have 3 plus 2 plus negative 6. Everything is square. So you see 3 is here, 3 is here, 2 and 6. So this is also going to give you 7 meters. Okay. So now next steps to get the unity vector, like I mentioned before. So the unity vector for AB, this is going to be the following here. The unity vector lambda AB, this is a vector. This is going to be equal to the component of the vector AB divided by the magnitude of AB. And the components are 2, negative 3, and 6. So we have here 2 over 7, and this is going to be my y direction, plus we have the second, which is negative 3 over 7. This in the j direction, which is also y. Okay, and then we also have the third one, plus negative 6 over 7 in the k direction, which is also known as x. For those of you who are not familiar with this term, okay, this here means the x component, this one means the y component, and this one here means the z component. So those letters here, I, j, and k, they respectively means x, y, and z. So if you did the unity vector for AB, now we need to do the unity vector for AC. So we do the lambda AC, that's going to be the unity vector. This unity vector is going to be the vector AC over the magnitude AC. Okay, this is a vector. And then we are going to do the same fraction. In this case, it's going to be 3 over 7 plus 2 over 7 j plus negative 6 over 7 k. If you see here, I'm also putting the positive sign in everywhere, and then I put the negative sign that comes from the vector. I think this is easier for understanding. So now that I have the unity vector, I get many questions when teaching problems like this. Why do we get the unity vector? And the reason why we get the unity vector is because this vector here, the size of it is 1. Okay, so the size of this vector, I would say, is 1 meters. So if this vector, the size is 1, and I want to multiply this vector to make it to my force, which is 700 and 560, I just multiply this 1 times the fraction that I have here. So basically what you're going to do is, for the force FB, we have the following. We have my 700 times my unit vector. Okay, and as I just mentioned, the unity vector here, this is basically 1, but this is in a vector form. And then when you do this multiplication, we have 700 times the whole vector here, which is 2 over 7 plus minus 3 over 7 plus minus 6 over 7. Obviously, if you have 700 divided by 7, they're going to cancel out here. Okay, so this calculation is going to give us 200i negative 300j and negative 600k. Okay, and again, you're going to do the similar situation for FC. So FC here we have 560 is the force times lambda AC, and this lambda is the unity vector, is also 1. Okay, and here we have 560 times the vector AC, which is 3 over 7 plus 2 over 7 plus negative 6 over 7. And then if you do this, you're going to get 240 plus 160 minus 480. And then once you have all these numbers right here, what you can do is do the summation of those two vectors. So the resultant vector fr is going to be the summation of the vector b plus vector c. Okay, this is all vector, and then we have those vectors right here, and then we have to do the summation for every single component. So in this case, I have 200 plus 240 in my x direction, plus I have negative 300 plus 160 in my j direction, plus negative 600 minus 480 in my k direction. Okay, so if you do this calculation, you're going to find out that fr is going to be equal to 440, okay, minus 140 in the j direction, minus 1080 in the k. So that's going to be the resultant vector. Okay, so, but this is a vector. If you want to find the magnitude of the resultant force, you have to take the radical like we did in the very beginning to get the magnitude of the vector a and b. Here we had 7 and 7. So in this case, you do the radical of 440 square plus negative 140 square plus negative 1080 square. And in this case, it will give you a value of 1174.56 newtons. You can rearrange it here, and then you can basically say the resultant force, the magnitude of it, is 1.17 kilonewtons. Okay, if it's in newtons, this is also kilonewtons. So here we have the resultant force. All right, and then the problem asks to find the coordinate direction angles. So to get the angles, it's pretty simple. You just need to divide the x component of your vector divided by the magnitude of it, and then you have the angle for each direction. So if I want to get the theta x, is going to be the cosine inverse of 440 divided by 117. Okay, remember this is in kilonewton, this is in newton. Actually, let me put it the value in newtons. Is 1174. Okay, so if you do this calculation, you're going to find this one to be 68 degrees, and then if you go to the theta y, it's going to be the cosine inverse of the y component, which is negative 140 over 1174, and that's going to give you 96.8. And for the theta z, if you do this calculation here, you have the inverse of the cosine as well, and here we have negative 1080 divided by 1174, and this is 157 degrees. Okay, so now it concludes this problem. Theta x, theta y, and theta z, they are 68, 96.8, and 157 respectively. Okay, thank you for watching. I see you guys in the next video.